In this example, we're going to write another polynomial function, polynomial g of least degree with rational coefficients, leading coefficient 1, but it has the zeros 1, 3, and 2 minus square root 5. So if it has 2 minus square root 5, it also has 2 plus square root 5. So the 1 and 3, they're not bad. They will be the factors x minus 1 and x plus 3. Remember, the reason, minus 3. The reason they're minus 1 and minus 3, it's x minus whatever that value is. So x minus 1, we don't keep that extra set of parentheses in there. I don't know why I put it in there. We don't keep that set of parentheses in there. We just rewrite it as x minus 1 without that extra set of parentheses. So like up above, say we can just change it here. If this were a factor of negative 3 or a 0 of negative 3, we wouldn't say minus negative 3. We just write it as x plus 3. That's why we do that. So when we're trying to come up with the factors for this 2 plus and 2 minus square root 5, it's always x minus whatever your 0 is. It's just that we have to remember we have the 2 plus and the 2 minus. So for these, we will write that extra set of parentheses in there. So I simplify it to make it look a little nicer. So I make this x minus, because the negatives distributes in there, x minus 2 minus square root 5, and x minus 2 plus square root 5. The x minus 1 and x minus 3, I'm going to just rewrite that as x squared minus 4x plus 3. If you guys actually did like a generic rectangle or foiled that out, x minus 1, x minus 3, x squared minus 4x plus 3. So now, we can multiply those radical parts together. So I would probably make a generic 3 by 3 rectangle. Might be the easiest way to keep this organized. One side being x minus, that's really bad, x minus 2 minus square root 5, and then the other side being x minus 2 plus square root 5. So x times x, x squared, and x times negative 2, negative 2x, x times square root 5, we'll just write as that. Looks a little weird, but it will eventually cancel. And then keep going, x times negative 2, negative 2 times negative 2 is 4, negative 2 times square root 5 is negative 2 square root 5. So don't make that 10. They're not like terms. We don't want to multiply them together. And then x times negative square root 5, negative x square root 5. Negative 2 times negative is positive 2 square root 5. And then negative times positive is negative square root 25. So all of these, like the negative and positive x square root 5, the positive and negative 2 square root 5, they all cancel. And what we're left with, this just becomes negative the square root of 25 is 5. So this whole box becomes x squared minus 4x minus 1. So this whole thing that we just multiplied, x squared minus 4x minus 1 times what we had already, x squared minus 4x plus 3. So then you guys would have to just do one more, either foil or 3 by 3 box. So if you did do another 3 by 3 box, we can just keep going with that. That's fine. One side would be x squared minus 4x minus 1. And then x squared minus 4x plus 3. So x to the fourth, negative 4x cubed, negative x squared, negative 4x cubed, positive 16x squared, positive 4x, positive 3x squared, negative 12x, and negative 3. So just combine your like terms that you guys have here. So only one x to the fourth, so just x to the fourth. And that's what the lead coefficient of 1 is saying. If you guys don't add anything to your x, that lead coefficient should always be 1 x to whatever power. Our x cubes, we get negative 8x cubed. And then we've got 3, 16, 19 minus 1 plus 18x squared minus 8x minus 3. So it's a lot of multiplying things out, but that is really just the big idea of it. You just have to multiply pieces at a time. So it will give you, the problem will give you the zeros. You have to come up with those factors to then multiply together.